All right, we're Unit 4 Calculus, Day 28, Part 2. Consider the graph of the circle to the right and the equation of the circle in implicit form below. So that's not as y equals, that's explicit form. So it looks like this is the center of my circle. So center looks like it's at 3, -2. I have a radius equal to 5. And just to remind everyone, hey, we know it's going to be x minus h all squared plus y minus k all squared equals r squared, with h and k being the center, and obviously r is the radius. So when we come up with the equation of that circle, it's going to be x minus 3 all squared plus y minus a -2, which would be plus 2 all squared, equals 25. So that's implicit form of this circle. Now let's implicitly differentiate the equation of the circle. So what I'm going to do, let's take the derivative of this first part. I have to use the chain rule. So it's going to be 2 times x minus 3 all to the first power times the derivative of what's inside. Now that's just an x. Derivative of x is going to be 1. Derivative of 3 is going to be -3. Now let's take the derivative of the second part. Again, bring the 2 down front. 2 times inside stays the same, comes down to 1. Now, when I take the derivative of the inside, derivative of y is 1, but we're taking it with respect to x, so it's going to be 1 dy dx, and then the derivative of 25 is 0. Now my whole goal is to solve this for dy dx. So let's first bring this over to the other side. So I'm going to subtract 2 times x minus 3, so that'll go to 0. Whatever I do to one side, I have to do to the other. So let's write down what I have. I'm going to have to give myself a little more room here. So I'm going to have 2 times y plus 2 all times dy dx equals -2 times x plus 3. Now let's get dy dx by itself by undoing the multiplication. So I'm going to undo multiplication by division. 2 times y plus 2. Obviously that's the same, so that's going to cancel out. So I get dy dx is equal to, and these 2's are going to cancel out. So I get negative x plus 3 all over y plus 2. Okay, and that's a great example of using implicit differentiation. Okay, and now let's complete the table below. Before I do that, I just quickly noticed one of my mistakes. When I subtracted, it's x minus 3, and of course I wrote it as plus 3. That's going to change some of my work down below. So let's take care of that now. So it's going to be x minus 3. Again, it's negative x minus 3 all over y plus 2. Okay, so down below on this page, just complete the table below, finding the value of dy dx at each of the indicated points. Then draw the graphical representation of the tangent line on the graph at each indicated point. So let's go back again. What does the derivative mean? It means the slope of the tangent line. So when I'm given this point, again, every one of these points has an x-coordinate and a y-coordinate. So now we're going to take what we just found for our derivative, which is dy dx, and I'm going to substitute in what I know. Well, x is 0, so I have 0 minus 3. Y is 2, 2 plus 2. So the opposite of -3 is going to be +3 over 4. And now let's go back up to the previous page, or up above to the graph, and at 0, 2, let's draw the tangent line, and let's see if that corresponds to having a slope of 3/4. So here's 0, 2. Let's pick this dash green line. So let's check out the slope. So if I count here, if I am, off, but if I go up 1, 2, 3 over 1, 2, 3, 4, that's a real good representation of the tangent line to the circle at point 0, 2. And the dy dx said that it must have the derivative at that point is going to be equal to 3/4. And notice when I do implicit differentiation, I need both the x and the y coordinate. When we did explicit, previous to this, we just said when x equals 0 or x equals pi or x equals -3. But now that my dy dx, we found have both an x and a y in it. All right, so let's keep filling in this chart. So this next one, dy dx, 3, 3, so it's going to be -3 minus 3 all over 3 plus 2, which 3 minus 3 is 0, so it's going to be, again, -0 over 5, which is just 0. And hey, what did we learn when the derivative is 0? That means I'm going to have a horizontal tangent. And so let's look at that at point 3, 3. So here's point 3, 3. I'm just going to keep using this dashed green line. Hey, there's my horizontal tangent. All right, let's do the next one. So again, I'm going to let x equal 8, so it's 8 minus 3, and then I'll let y equal -2, -2 plus 2. 8 minus 3 is 5, so we're going to say, hey, -5, but it's going to be all over 0. Uh-oh, that's undefined. And when it's undefined, that means we now have a vertical tangent. And let's look at that on the graph. Let's come back here, and we're at 8, -2, so I go over 8, down 2. That's at this point. Let's go my tangent there. And hey, that represents that vertical tangent. Okay, so let's keep going with the chart. dy dx equals opposite x is 3, so I have 3 minus 3. And then y is -7. -7 plus 2. I can see right now I'm going to get a 0. Doesn't really matter what it's over, well, as long as it's not 0. So it's going to be 0 once again. I'm going to get a horizontal tangent. And let's look at where that is on the circle. Just change pen here. So that was at 3, -7. That's right here. Let's draw that tangent line. Once again, that tangent is a horizontal tangent, which means its slope is 0, which is what we're getting. All right, let's keep going with the chart. So the next point is 6, 2. And these are all the points where there's integers, both the x-coordinate and the y-coordinate on the circle. Obviously, there's an infinite number of points on the circle. We're not going to do infinite number of examples. So let's let x equal 6. So I have 6 minus 3. And then 2 plus 2. 6 minus 3 is +3, but there's the negative out front, so it's -3/4. Let's put this on the graph. And that was at 0.62. So that's over 6 up 2 right there. Looks like it's symmetric to the vertical axis of symmetry. Let's now put the tangent line there, and we're getting -3/4 for slope. Okay, last 2 points. So x is -2, so -2 minus 3. This is going to be -2 plus 2, so it'll be -5, but the opposite, that's +5. 5 over 0, again, undefined, so vertical tangent. And let's put that on the circle. Okay, so -2 to the left 2, down 2, that's this point right here. So when we look at the tangent, again, we see that it's a vertical line. All vertical lines have an undefined slope. All right, so the last one, and this will be it for part 2 of the notes. Okay, and we have 6, negative 6. So we said it was the opposite of x minus 3, so it's going to be 6 minus 3 all over negative 6 plus 2. And 6 minus 3 is going to be 3, but then I'm putting that negative to the numerator in this case, but it's going to be negative 3 over negative 4, which will be positive 3/4. Okay, which ends up having the same slope. And again, where was this point? It was 6, negative 6. Um, over 6, down 6 is right here. Let's look at that slope. This tangent is the same slope as that tangent over there. So this one was positive 3/4. This one was positive 3/4. So they are parallel to each other. Okay? And that's where it's helpful writing the equation of the circle in implicit form and then using implicit differentiation. Again, if I know the xy coordinates of the points, then I can find the values of the slopes of the derivative, or slopes of the tangent line, which is what the derivative stands for. All right, that's part 2.